No one join still, so I'll wait for a minute. Then after I'll start or I'll record the video. So now I want to start. Still no one join. So I'm going to record the video and in future student can access. So welcome in the week 6 fluid mechanics TA session. So today we are going to discuss about the fluid kinematics. Very important topic from your final exam point of view. And basically the topic covered in this topic, the fluid kinematics, the lecture 1 was about the Lagrangian and the Eulerian description. Lecture 2 was about the motion and deformation of fluid elements, and lecture 3 was about fluid kinematics. That was the problem solving session. So now let us move with the next slide. So basically in the fluid kinematics we analyze the motion by two ways. First one is your describe the detailed flow pattern at every point in the flow field, which is your differential approach. Another one, working with the finite region, that is control volume approach. So these two approach you have. First one is the describe the detailed flow pattern at every point. If you have a flow domain like that, at every point you have to describe the flow pattern every point. But in the control volume approach, what you will do, you have the flow domain. In flow domain you will select some control volume, and in control volume you just try to measure the your flow patterns. So these are two way, and once we'll go in the next, will further slide will discuss more about it. So now let us move with the next question or next slide. Next slide we have the question, which all topics are have covered in the class, but let us discuss with the questions. So the first question is about the convective acceleration of a fluid particle in the direction of x. So here question is about convective acceleration. You have in fluid mechanics, basically you have two types of acceleration. One is local and another is convective acceleration. So you have two type of acceleration, and so here question is asking about the convective acceleration, not your this local acceleration. So what is local, what is convective, I'll discuss. So let me discuss because no one here, so I'll not wait. So let us suppose initially from your mechanics, engineering mechanics, whatever you have learned in your previous semester, the acceleration is in simple way, if I write change in velocity with respect to time. This is your for the solid. This definition is for solid. You can use this formula directly in the solid mechanics, but once you will come in the fluid mechanics, and when you derive this acceleration using your control volume approach, whatever we have discussed earlier, the acceleration formula become like that: ax, acceleration in x direction, I, acceleration in y direction. We are, because we are discussing about here the three-dimensional flow, and j and w, awk. Here we can give the cap. So like that. So what is the expression for x direction? So let me just write del u by del t plus u del u by del x plus v del u by del y plus w del u by del z. Similarly for your ay, what will change here? At the place of u, v component will come, because your velocity have three component, u, v, w, because three dimensional velocity. So we are discussing about here the three dimensional acceleration, so that's why I'm writing acceleration in the x direction, acceleration in the y direction will be the at all u places we will replace with the del v by del y, w del v by del z. Similarly for az, x, y, z here you will write. For az, del w by del t plus u del w by del x plus v del w by del y plus w del w by del z. So these three formulas you have for acceleration in separate direction. Here the all these three term, that is which is associated with your time, this is known as your local acceleration. This is local acceleration, and the remaining all terms known as convective. So now the question is asking about only the x direction, so ax. So ax for convective acceleration only, u del u by del x plus v del u by del y plus w del u by del v. So this will be your correct explanation. So which one? U del u by del x, v del u by del y, w del u by del v. This will be your correct answer. So now, so like that you need to select the answer or interpret the questions. Now let us move with the next one. So next question is, for a two-dimensional fluid element, you have the two-dimensional here, expression is, and why I was focusing in the previous question three-dimensional, because of, as we will see the option, you have the x, y, z. So that's why according to option you have to think about it. Okay, so now let us move. For a two-dimensional fluid element in xy plane, okay, the rotational component is given by, so here you need to calculate the rotational component. Means rotational component, if you have something, let us assume xy plane like that, you have the plane like that, this is your x and this is your y. So whatever the rotational component will be your z direction, this is your z, so this is your x, this is your y, and this is z. So here you need to calculate the rotational component, and this will be your wz. Here wx, the notation for the rotational component is wx here and wy. So here you have xy plane, so in xy plane for rotational component you will go with only this wz. So because rotation is only possible in wz direction in xy plane. So let us write the expression, or you have to remember this. For wz, this will be half del v by del x, remember please, minus del u by del y. So sometimes in the gate, this expression, based on this expression, you will find out the question, lot of questions in fluid kinematics, remember please always. So now let us move with the next question. Here is the concept, what is kinematic, and how you will define what is Lagrangian description, what is Eulerian description. So I think sir has discussed very well so I'll not move, and I'll upload this content on your Google Drive. If anyone have any doubt, we can discuss in the next class. You can ask, because all these things sir has discussed already in the class. So what is velocity, what I was discussing, the velocity vector how we will write, and acceleration vector how we will write, so like that. And what will be your velocity, this formula remember please, because this will I'll use in the question answer. So velocity, if someone tells you, you find out the velocity. So in three dimension, if the explanation is three dimension, so ui and vj and wk, so you have these three component. So first you will calculate u, then v, then w, and then you can write, that is your u is, v vector is u, whatever you will get, let us suppose here you get 10, this is your 2, and this is your minus 3. So 10i plus 2j minus 3k. So this will be the final answer. So like that we'll discuss, like that I'll solve the problem. So now let us move without any delay to the next question. So these questions I have some put it example here, so you can go through it also. And okay, so acceleration of the fluid particle, whatever I was discussing, the change in velocity with respect to time, but how you will write, like that, the derivation here is also here. So these all these things are as discussed very well. So here we are going to focus only on the question answer. Okay, the next question is, the shear strain rate is given by, shear strain rate. Question is asking about shear strain rate. Question number 3. Shear strain rate. Whether recording is going on or not. Yeah, recording is going on very well. So you have to find out shear strain rate. So okay, so shear strain rate is your nothing, just you have to understand half, direct formula, half del v by del x for shear strain rate. You have to understand the things, whether del v by del x, let me just write the 2 del u by del y, or two option here is similar, so that's why I'm writing, just you try to understand. And del u by del x plus del v by del y, so which option should be correct? Just think on that. For this question here we have the expression, the some concept relating your shear strain, how it link with the your component, and what was the rotational what we are discussing previously, here you can see very easy. And how you will calculate, here the explanation is given very well, rotational, and some theory is also given. Whatever the turn angle you will find out with respect to the line A and line B, you will take the average, and for averaging you will get the final expression del u by del x minus del u by del y. And also I have explanation, so I want to just show you whether it is here or not. Yes, here we have. That's I want to show you. So here the question is about the strain rate, shear strain rate, and here we have the explanation how we calculate the shear strain rate in the question. So here is the similar thing you will find out, that is change in angle A to B, change in angle A to B, and with respect to time, so the final expression will be your half del u by del y plus del v by del x. So you can match this answer, del u by del y. So here your final explanation will be this one, half, you can match del u by del y plus del v by del x, or whatever you can write this first and later del v by del x, later del v by del u by del y, like that. So now the next question is the vorticity is given by, the vorticity is given by 2 times of the rotation, option B 1.5 times of the rotation, and option C the 3 times of the rotation, and option D equal to the rotation. So for these questions I have also the explanation, that is the detailed explanation about it. So let me just show you fast whether I have, or yeah, I have, I think. Let me just, yeah, here you can see very well the vorticity and rotationality. So once you will see this video, first you please read this whatever the explanation is given here. Once you will read this explanation, you will very easily you can give the answer. Here you can see the final explanation. After the final explanation, you can find out your vorticity is equal to twice the angular velocity. This is your vorticity. So your vorticity is equal to, or your omega vector is divided by 2. So here you can write your vorticity is equal to 2 times of omega vector. So this is your final explanation. So here the direct question is from this book, that is Sinjal Sembala book. The vorticity is given by 2 times of the rotation. So this option A will be correct for this. So hopefully you will got it. Okay, now hopefully you will comfortable with this explanation. So if anyone have any doubt, we can discuss in the next class. Okay, I think sir has discussed very well about it, the virtual fluid ball concept. This is also from your Sinjal Simbala book. You can find out this the detailing behind it, or you can read itself here once I'll upload this PDF in your Google Drive. Now let us move with the next question. Here again one example is there. So once you will vorticity contour in 2-dimensional flow. So here the question is about vorticity contour. So once you will read this problem and the solution, you will find out very easily. Very important. Once you will see here, let me just read. The boundary layer separation of the wall at the corner, here you can see the boundary layer separation. Here you can see the boundary layer separation is happening. boundary layer separation of the wall at the corner of the body from a thin shear across which the velocity change. Here you can see the change. Okay, now let us move with the Ravi. I am audible, please just confirm. Hello.
Yes, sir.
Okay, okay, fine. So actually, I have discussed a lot of questions before you coming. So actually, the class is scheduled from 7. So already I have taught the 26 minute, 25 minute, 20 25 minute. So what I have discussed, let me just show you. Very few questions actually. I have discussed a lot, but we have covered only very few questions, not much. Let me just, I want to just show you. Here you can see this was the first question. What is convective acceleration? So this we have discussed already. The what is convective acceleration. Another question was about what is your rotational component in xy plane. So this we have discussed. And another question we have discussed. By the way, we have the question related to these above two questions. We have in the whatever in the coming slides we have the questions. The shear strain rate is given by, here also we have discussed, and verticity also I have discussed. So now let us move with the fifth question. Question number 5. Which of the following factor affect the verticity? Which of the following factor affect the verticity? Viscosity, temperature, both A and B, none. So please just try to give your answer. Verticity. So here you can see, before discussing this question, let me just show you the verticity explain. Where is, yes, here you can see the verticity expression. The verticity is depend on your velocity, that is the curl of velocity, you can say directly. So whether it is related with temperature, viscosity and all, from here you can think about it. Okay, so now please you just try to get the answer. Which of the following factor affect the verticity? Okay, you are telling A. Okay, good. So here you can just think on that, because your verticity is not related with your viscosity and temperature. So here you can say very clearly none of the above. We are talking about the verticity. Okay, the next question is, the study of fluid motion without considering the force causing the motion is known as static of the fluid, kinematics of the fluid, dynamics of the fluid, none of the above. So please just try to write your answer. Just please first read the question very well, then you try to write your question. for the okay. Okay, Ravi is telling option B, fluid kinematics. Okay, fine. Other student, please also you can write the answer for question number 6. Okay, so let me just discuss. So actually for the previous question, question number 5, the correct answer was about the viscosity. So I think Ravi was correct, the previous question. The which of the following factor affect the vorticity? Because we have the expression here, the expression for vorticity is this one, the curl into your the curl of velocity. Just I want to write here, curl of velocity. So here we have not term any the viscosity and temperature, but the final explanation for your vorticity in fluid dynamics, actually we have the final explanation like that. The vorticity transport equation, in the vorticity transport equation we have the term of your viscosity, so it is directly affect the your vorticity. So the option A will be correct, please remember. So based on that I was telling no, but this is not correct, so option A is correct for them. Okay, now moving with the question number 6. The study of fluid motion without considering the force causing the motion is known as your kinematics of the fluid. Yes, very good. Option B is correct here. Now let us move with the next question. The approach of identifying or tracking, I think my video is not visible. The approach of identifying or tracking the individual fluid particle by its position, velocity, etc., and described as a function of time is Eulerian approach, Lagrangian approach, static approach, none of them. Which option will be correct for question number 7? Please just try to write your answer. For question number 7. Here you are tracking the individual fluid particle. Please think on that. Okay, the content related to this question already I have given in the above slides. So once I'll upload this PDF, you will find out the content as well as question also. So let us discuss first the question. Content sir has already told about it. So I'll wait 1 minute more. So please just try to. Okay, you are telling B option, that is a Lagrangian approach. Okay. So yes, when we tracking the individual fluid particle, we'll go with the this approach, the Lagrangian approach. Okay, the study for a steady compressible flow, the continuity equation can be taken the form this one, A1 V1 equal to A2 V2, rho 1 V1, rho 2 V2, this one, and option D. Which option is correct? For a steady compressible, here is, remember please, we are talking about the compressible flow, steady compressible. So which option should be correct? So please think on that. Okay, Ravi is telling option C. Okay. Yes, option C will be correct, because for incompressible your rho will constant. Once the rho will constant, from both side you can cancel out. But for compressible flow, rho is not constant, so you will go with this. Remember, option C will be correct. For compressible flow, your when the rho will be constant, incompressible, this formula will be valid. But here is compressible, remember, that's why we are moving with this. Okay, now let us move with the next question. Question number 9. The flow in which velocity of a fluid at particular fixed point change with time: unsteady, oscillatory, steady, periodic. The flow in which velocity of fluid at a particular fixed point change with time. So please just try to write your answer in the chat box. Which options would be correct for question number 9? Today I have lot of questions, so we'll solve lot of questions regarding your this fluid kinematics. Okay, the question is about, let me just discuss. You have to find out, let us suppose this is your channel and water is flowing like that. You want to measure velocity at that point. Initially, at t is equal to 2 pm, your velocity was this is point P, was 1 meter per second. At t is equal to 220 pm, your velocity is at the same point is 1.5 meter per second. At t is equal to 3 pm, your velocity at the same point is 1, or say 1.2 meter per second. So changing with respect to time. So such type of flow we know with this name, unsteady flow. Remember please. If not changing with respect to time, let us suppose at 2 pm your velocity is 1, and at 220 also 1 meter per second, and 3 pm also 1 meter per second. So in such case the flow will be steady flow. Very basic. So now the next question is, a velocity field is given by u is equal to minus 3x, v is equal to 2y, and w is equal to z. Is flow steady? Question is here, is flow steady? Yes, no, can't say. You have three components of the velocity. So whether this indicating steady flow, as you know velocity is x, y, z, t. Depend on these things. Maybe depend, or sometimes not depend on t. So as I have discussed in previous question, what the mean of steady. So if you have, just think on that and try to write your answer, whether yes or no, or can't say with this data. ABC, which option will be correct? Or let me write in the minus 3x I 2yj zk, like that. So here is no t term, so it is not depend on your time. So if yes, definitely it is a steady flow. So the next question is question number 11. The velocity vector in a fluid flow is given by this explanation. This explanation is, yes, this explanation is given 4xqy minus 10x square yj plus 2tk. Find the velocity of the fluid particle at 213 at time t. Write magnitude only. So okay, so please just try to calculate. The expression is, let me just write the full expression. I minus 10 x square y plus 2 tk. using this velocity description in x, y and t or z also, this is 2 not z. Okay, so you have to calculate your velocity. This is velocity vector. So what should be the velocity? At 2, 1, 3, this is your x, this is y and this is z, and t is equal to 1. 1 second you can say. Here unit is not written, but you can consider 1 second. So please think on that, how you will calculate. For your easiness, let me just write the final expression. Uy Vj Wk. So from here you can write U is equal to what, V is equal to what, W is equal to what. Calculate UVW at your 2, 1, 3 and T you can say 1. This is X, Y, Z, T. And finally, after that, you will calculate the magnitude. So for magnitude, after getting the value for magnitude, you will go U square, V square, W square. Finally, you will get your answer. $51.26. I think I have already solved. So let me just match. Yes, you are correct. So not visual, let me just write here. So your U is 4x cube. So 4 into 2 to the power 3, because x is here 2, because 2 is given, x, y is 1 and z is 3. So this will be your 32. V is your minus 10 x square y. So here is minus 10 into x square 4 into 1. It will again minus 40. W is equal to 2t. You have t is equal to 1. So 2 into 1, this will again, this will 2, positive 2. So here is no meaning of positive and negative, because you are going to finally square root. 32 square minus 40 square plus 2 square. Finally you will get 51.24. This will be your in meter per second. Or here time is not given, so this is magnitude is asking. So if the distance is in meter, then you can write finally, and time in second you can write in meter per second. Okay. So the next question is, find for the above problem, find the acceleration in x direction. Here you need to find the acceleration in the x direction for the same question, for this same expression and same point and same time, everything. You have to find out the acceleration. So please just try to calculate acceleration. So I am waiting, please just try to calculate. Here you need to find out only the acceleration in x direction. So the expression for x direction acceleration, actually already I have discussed in the first question, but that time no one joined. Let me just write again. Okay, so ax is equal to del u by del t, because in x direction you are considering u, plus del v by u del u by del x plus v del u by del y plus w del u by del z. So this is your the formula for ax, or acceleration in x direction. So you need to find out this only. So here also you need to write the magnitude. So we'll take the square root after your final answer. For this question I have also calculated whether, yeah, so here only one, that is ax, so here is no meaning of a square root. So whatever you will get the answer direct. Yeah, if you are minus, if your answer in minus, then the meaning of square root will be considered. Otherwise, if you will get the positive, there is no meaning. Because once you will get the minus, when you will square root, take the square root, that the final answer will be affected with the sign only. So the question is itself written the right magnitude only, means there is no sign, minus, plus, there is no. Whatever you are getting, in whether is positive or negative, you just write down only the numerals, numerical value. Very easy question. You just differentiate the value and you will get final answer. You have to use the same expression for, that is the same point 213 for xyz and t for time. Okay, let me just discuss. So here you have this 4xy. So for du by dt, there is no t term, so this will be 0. Du by dx, this will be your 4 into 3x square, that is 12x square. So here is 0, and plus u value is 4x cube into 12x square, plus what is the v? Okay, v is fine, but let me just calculate del u by del y. So del u by del y will be the 0 because there is no y term in the. So this will be 0. Once you will multiply 0 with u, then finally 0. And del u by del z, whether it is any z term, no. So again del u by del y del z will be the 0. So this term will be the 0. The final outcome is 4x cube and 4 12 4 the 48 x to the power 5, where I am correct or not. Yeah, 4 3 is a 12, correct. X to the power 5, yeah. So 48 into x to the power 5 is how much? 32. Why? Because x value is 213. So here x value is going directly 2. So once you will multiply final expression, let me just multiply. 48 into 32. 5136. Yeah, if everything is meter and second, then meter square per second you can write. Okay. So like that you will solve. Whether I'm doing mistake somewhere or u, then 3x square and 3 4s are 12x square. Okay. So here 12 and 4. Yes, fine. Yeah, everything is fine. So now let us move with the next question. Yeah, okay. 5136. So question number 13. Yeah, Ravi is correct. For the velocity field, you have this velocity field. Let me just write v is equal to zi plus xj plus yk. You have expression. Find the material acceleration at vector at x is equal to 1, y is equal to 4 and z is equal to 1. So here you need to find out material. So what is material acceleration? Let me just discuss here. So this is your material acceleration, dt del v by del t plus this is your material acceleration, or sometimes you will write like that, meaning total acceleration. Just terminology, I j, I will write here, and k. So what you will do here, calculate ax, calculate ay, calculate az, and then put the value here, you will get the final answer. So remember please, material acceleration is nothing, just total acceleration in all three directions. You can write, you can tell, you can remember these things. So what is ax, what is ay, and what is az? So I have already discussed here the expression for ax expression, similarly for ay expression, similarly for az formula. So del u by del t plus del u by, first will come u, del u by del x v del u by del y plus w del u by del z. Similarly here you will write full expression for with v. This will not change, but v del v by del x, v del v by del y plus w del v by del z. Similarly for this, del w by del t plus u del w by del x, v del w by del y, w del w by del z. So this is the final expression. So from here you need to calculate ax, ay, az. So you have 5 minutes. Within 5 minutes, please just try to calculate. Very, very important question. After this question, I'll take 2-3 minutes or 5-minute break. Then we'll move on the question number 14. So I'm waiting for your question. Please just try to. Okay, let me just discuss. So here you can see the your, let me just first write u is equal to you have z, and v is equal to you have x, and w is equal to you have y. So del u by del t, this will be 0. U, first del u by del x, this will be 0. Del u by del y, this will be 0. Del u by del z, this will be 1. 1, and w is equal to y. So with this you will get only y. Only y you have. From here, del v by del t, whether it is any term, no, this will 0. Del v by del x, Here you have del v by del x, so 1, and u is equal to z. So z1, okay. Del v by del y, no. Del v by del z, no. This will again 0. There is no expression for x, y and z, so this will again 0. So you will get from here only z. Now del w by del t 0, del w by del x 0, del w by del y, yes, you have 1 and v value is x. Del w by del z, no, again 0. So here x, you will get from here x. So ax is equal to your y, I, ay is equal to z, j, az is equal to x, k. So from here you can put the value x, y, z is given 1, 4, 1. So here you can write 4i because y is equal to 4, z is 1j and k is 1k. So 4i plus j plus k. So this should be your correct answer. 4i plus j plus k. Option C will be correct. So hopefully you all got it. You both got it. Now let us move with the next question. Yes, here from I'll take 5-minute break. So in between you can solve the question. A velocity field is given by u is equal to minus 3x. You can also take break if you want. U is equal to 2, v is equal to 2y. Let me just write very clear. 3x, v is equal to 2y minus 3x, remember, and w is equal to z. X, y, z value is given 1, 1, 1. Find the local acceleration. Here you need to find out local acceleration. So please just try to calculate. I am going for 5-minute break. Okay, so now let us discuss the velocity field. Here is the expression is given for u is equal to this. Here we need to calculate the local acceleration. So the local acceleration, as I have discussed already, these three term or local acceleration means the velocity associated with your time. So this term is your local acceleration. This is. So in AX, you have local acceleration del u by del t. In AY, you have local acceleration del v by del t. In z direction, acceleration is del w by del t. So del u by del t means what? Minus 3x. Okay. So here you have not the t term. So this will be 0 because here is no t. So once you will differentiate the part in, once you will differentiate, you will get 0. Here in v also and w also you have not any function of t. That is, your w is not a function of t, v also not a function of t, and u also not a function of t. So your acceleration, local acceleration will be 0. Okay. So I think no one joined still. Okay. So the next question is question number 15. For the above question, that is for this expression, find convective acceleration. Write in SI unit. So convective acceleration, here your u value is minus 3x, v is 2y, w is z. So you have to find out convective acceleration. Ax, Ay, Az. So what should be the convective acceleration here? So the formula for convective acceleration is u del u by del x, v del u by del y, w del u by del z. Similarly for y, u del v by del x, v del v by del y, w del v by del z. Again for your z, u del w by del x, v del v by del w by del y, w del w by del z. So here you will find out this will be minus 3x, and when you will multiply, when you will differentiate, you will get minus 3 again. That is 9x. Finally you will get 9x, and your u component have not any the expression for y. Your u is not a function of y here, so this will be 0 again here also because your e is not a function of z. Now coming with the ay. So ay here is u is 3x, but whether your v is a function of x, no, so this will be 0. V is your 2y, and v is a function of y, yes, and again you will get 2, so this is your 4y. And whether your v is a function of z, no, here is only y, so this is again 0, so we will get this. Now coming on az, So u value is 3x, whether it is function of x. W is a function of x. No, again 0. Here again 0. But this one W, this will be 0. But this W is a function of Z. So you will get 1 here. So you will get Z. So final your A is equal to AXI, AYZ plus AZK. So 9x I, this x is associated with this, plus 4yj plus your z. Okay, here you have 1 1 1. So let's just put your vector A 1 comma 1 comma 1. So 9x 9i plus 4j plus k. But you need to, here is the option is not, so I think here you need to calculate the magnitude. 9 square, 4 square, 1 square, and finally you will get 1 comma 1 comma 1. 81 plus 16 plus 1. So here is 8 and 9. So this will be your final answer for question number 15. That is your convective acceleration for this expression. So here conclusion is, this expression is the steady flow, whether it is uniform or non-uniform. So whether it is uniform or non-uniform, steady is fixed because local acceleration is 0. But you have the value with change in your, you have some ax, ay and az also, because you have some magnitude as your x position is changing. The uniform and non-uniform definition is this. Let me just discuss the definition. If you have, let us suppose, flow, and you are calculating the velocity at particular time, let us suppose 10 am. So here you are measuring at a lot of place, let us assume this much. At all space, if this is your distance is x, at each x at particular time, if you are measuring velocity, so del v with respect to x is constant. That is, if here 2 meter per second, here 2, here 2, everywhere 2, 2, 2. Remember, 2 meter per second, here also 2 meter per second, everywhere. So this is the definition. So think on that, and we'll discuss in the next class, or you can comment also in the, once I'll upload the video. Okay, now the next question. A streamline is defined in terms of stream function phi and potential function phi. Stream function psi, this is psi, and the potential function phi as. So here you need to just think on that. whether phi will equal to constant, del phi by del psi equal to constant, del psi by del s equal to constant, del or only psi is equal to constant. A streamline is defined in terms of stream function psi and potential function phi as. Okay, so here I have the explanation. The stream function, as you know, by definition, streamline is a curve that is tangent to a velocity vector anywhere. Means you have a curve, so if you will take tangent, you will get velocity. If you will take tangent here, you will get velocity vector. If you will take tangent here, you will get the velocity vector. Okay. In 2D flow, the stream function psi is introduced such that u is equal to del psi by del y, v is equal to minus del psi by del x. Remember please, this expression will use in the coming questions. And del, okay, so first discuss this one. Along a streamline, psi has the same value everywhere. Along a streamline, the psi value have everywhere same. So if the value is same everywhere, means what? The psi is constant. So this expression is defined the correct streamline. Remember please, this is not. This expression is, that is your potential function related with your equipotential line. Line of constant phi, if the phi is constant of any line, that line known as the equipotential line. If a line have a constant psi, this is the definition of, or this is related to your streamline. Okay. Question 2. A flow has parallel curved streamline. A flow has parallel. This question I have already discussed in the previous class. So I'll not take much time here. The flow has curved streamline like that and steady. The flow has, because parallel, so your tangential acceleration will be constant. So that is, you have not any tangential acceleration, only normal acceleration will be active. How? So you can go with the previous lecture. So now let us move with that. Next question number 3. A flow is said to be rotational. Flow is said to be rotational when the streamline are curved, a velocity gradient in the normal direction to the flow exists. Every fluid element has finite angular velocity about its mass center. Every fluid element has an angular velocity about a common axis. Which option will be correct? A flow is said to be rotational when, just think little bit, a flow rotational means flow is rotating, means, let me just show you the expression. How physically, yes, here you can see, this is your rotational fluid particle. As you can say, the face is here, now face is turned like that, now face is turned, now face is turned like this, now face is, this is rotating, this is rotating fluid element. This is not, this is irrotational. How? As you can see here, so you can see here within the boundary layer, just the out of your discussion, this is out of discussion, within the boundary layer your fluid is rotating, out above the boundary layer flow is rotational. Remember, above the boundary layer flow is rotational, within the boundary layer flow is rotational. This is found with the experiments. The fluid particle always think, remember, within the boundary layer fluid particle rotate and above the boundary layer rotation. Okay, there are a lot of assumption here, so we'll not go in deep, but the question is this. So rotational, every fluid element has a finite angular velocity about its same mass center, so these options would be correct. The vorticity is 2 times of the rotation as I have discussed earlier, so there is no waste of time here. So next question is, velocity potential exists for flow of a perfect fluid only, steady rotational, all irrotational fluid flow, all 3-dimensional flow. So as I have earlier discussed, the potential function exists for all irrotational flow. This question I think also I have solved in the some 4th week. The line of constant phi. Oh, already we have here, we have seen the line of constant phi known as equipotential line. Whether the option is the line of constant phi are parallel streamline, are parallel to the streamline, are normal to the streamline. Yes, normal to the streamline. If this is a streamline, so your potential line like that. So this is will be your potential line if this is your stream. So remember please, normal. This question is very important for your gate point of view. I think in 2-3 times in the gate examination I have asked. So now let us move with the question number 7. So phi you have 3xy and xy here the component of velocity at point 1, 3. Oh no, phi is equal to x 3xy. The x and y component of velocity. Here you need to calculate x and y component. Means if you considering in x direction u and y direction is v, so you need to calculate u value and v value. So first you need to understand how your u is related with the phi and how v is related with the phi. So once you will understand these things, then you can very easily find out v is a function of phi. So for this is related. This is the relation between your xy. So here is the phi is equal to 3xy. So you need to put u is equal to del x, so 3y, and v is equal to del phi by del y, so 3xy, so here 3x, so finally, so u is equal to 3x 3y, whether, or you have the option 1, 3, the point you have. So u at 1, 3 is equal to your 9 and v at 1, 3 your 3. So u is equal to 9 and v is equal to your 3. U is equal to 9 and v is equal to 3. Okay, now the next question is question 8. Indicate the correct statement of flow net. Flow net means stream function combination of your potential function like that. So this is flow net. So this drawing is not correct, but just for the general interpretation. In application is applicable to irrotational fluid flow for a given boundary is the same whether the flow is one directional or other. For a given boundary is applicable to one chosen direction of flow. If the flow is reversed, the flow net will change and will be no constructed that the size of the mesh is inversely proportional to the local velocity. So this is 4 option. The incorrect option here is asking. So it means the 3 option is correct. So you have to think about it. Which option should be correct of question number 8. Yes. Very easy question. Okay. So is applicable to the irrotational fluid? Yes. For a given boundary is the same whether the flow is one directional or other. Yes, fine. For a given boundary is applicable to one chosen direction of flow. No, here is just opposite. So this will be the incorrect. And we'll know, okay. So this will be your, for this question, your option C is correct. Now, question number 10. Which of the following stream function phi is possible irrotational flow field? So here, which of the following stream function? You have the 4 stream function A, B, C, D, and you have to find out a possible irrotational flow field. Possible irrotational flow field means no rotation. Del psi by del x, so it is only 2. Del psi square by del y square, if it is equal to 0, so it will be the irrotation. The possible irrotational flow. So let me just go with the first one. So x square minus 2x del square y square minus x square divided by x square plus del square y square minus x square divided by del y square is equal to 0. So x square. So the first derivative is minus 2x, then again derivative is minus 2 plus the first derivative is 2, first derivative is 2y, again one is plus 2. So the first expression is correct. Will not go for other. Okay. So the next question is question number 12. If a velocity field is given by u is equal to 16y minus 8x, v is equal to 8y minus 7x, find the circulation around a closed curve defined by x is equal to 4, y is equal to 2, and okay, closed curve, and x is equal to 8 and y is equal to 8. Okay. Find the circulation. Means if you have something like that, this is your x and this is your y. So when the x is equal to 2, your y is 2. When the x is equal to 8, your y is 8. Or something like that. You have the close things. How this is close. So you have the more options. Around a closed curve defined by, okay, so something curve is which is close these two things. At x is equal to 4, x is equal to 8, and this is at 4, y is equal to 2 means here, and at x, y is equal to 8. So hopefully like that, I think. So this will be your 4 comma 2, and this will be your 8 comma 8. So like that, I think. Okay, so here you need to find out the circulation. So how you will find out? So here is the expression for the circulation. So using the Green's theorem for 2D circulation, so you have expression for like that. This one, u is equal to 16y minus 8x, v is equal to 8y minus 7x is given in the question. So del v by del x is equal to minus, because this will be 0, minus 7x. Del u by del y is equal to 16 only, because here you have not any y term, so only 16. So del u by del x and del v by del z, you will find out the final minus 23. And area of whatever the area you will find out, the area will be 4 into 6, that is 24. And your circulation unit Wz into area, your final answer will be 552. The circulation around the curve that is counterclockwise, that is positive, is minus 552. Remember please, that is in clockwise sense. You will remember, you can just counter 552 in the clockwise sense. Now next question, very easy question from your fluid kinematics. I have the 10 question, very easy. So the fluid kinematic deals with force causing the fluid motion, geometry of the fluid motion without force, yes, and thermodynamic of fluid and pressure distribution only. So we have discussed already in the previous question that this is just definition of the fluid kinetics, deals with the motion, not force. So here the expression is given, y correct option is B. Now the equation of continuity for incompressible fluid means rho is constant. So obviously this option will be correct, because this is not. So the expression is here is given. You can go one by one. The continuity, that is mass conservation, the differential equation is this. Differential form is this. Incompressible flow, that is rho is constant, and if the rho is constant, let me just del rho by del t plus rho del equal to 0. If rho is constant, this term will be 0, and this is again, if this term is 0, this is v, so you can write it, that is rho will also go this side, so only remaining is this is, so that's why. Okay, so the physically it means volume or mass outflow equal to inflow, no locally net volume change. The meaning is this. Next question, question number 3. A streamline is defined as the line tangent to velocity vector at a point, path traced by fluid particle over time, curve showing equal velocity magnitude, option D, path of highest energy. Streamline. So as we have discussed earlier also, the streamline tangent, the line tangent to velocity vector at a point, means once you will have a vector and once you will take the tangent, once you have the curve, if you have a curve and when we will draw the tangent here, you will get the velocity vector. Okay, so here you can see. Now, very important question. Which of the following is correct for laminar steady incompressible flow? Laminar steady incompressible. So, streamline equal to path line equal to straight line. Option B, streamline does not equal to path line but equal to straight line. Option C, streamline equal to path line does not equal to but does not equal to the path line does not equal to the straight line, and streamline does not equal to path line does not is equal to straight line. So which options would be correct? Think about it. Here you have laminar. So first you need to understand the definition of your streamline, path line and straight line. So let me just show you the definition. Streamline, okay, tangent to velocity at an instant. Path line, actual trajectory of a fluid particle of a fluid particle. Remember please, if this is flow path, if this is flow domain and you have only looking one particle and this is moving like that, so this is your path line. You have the flow domain and at a particular time you have just taken a picture, you have just taken the picture and you are analyzing. So what you will see, the lot of fluid particle will be like that. So that is the combination of lot of fluid particle here. Here you are only looking one particle, but at an instant of time you have millions of fluid particle, but the flow is like that. When you will draw a tangent, you will get the velocity of particle. So this is your streamline definition. Straight line, locus of particle that have passed through a fixed point, meaning the locus of particle, that is dye ejection. Let us suppose here you have a dye and some ink you are putting here. So it is like that. So this is asking the locus of particle, lot of particle, locus of particle means path of the particle, locus of the particle that have passed through a fixed point. Let us suppose here lot of fluid particle and going like that, the lot of fluid particle is going like that. So at a particular point wise we are discussing path line, and in streamline millions of the particle, and streak line little bit less particle compared to this. So remember please, so when the flow is steady means there is flow is not changed with respect to time, the flow is linear, there is no only straight flow, layer by layer flow is like that, incompressible, no density change. In such situation all three lines will be equal to each other. Remember please, this is very very important question. Option A will be correct. Now very easy question. The stream function phi satisfy which condition for incompressible flow? So as we have already discussed, if the 2D flow, this is valid only for the 2D flow, remember please. So the previous question was about discussing only 2D. Where is the, yes, here only 2D xy, so that's why this was correct. But here in general, where is the question, yes, the stream function satisfy which condition for incompressible flow? So the correct statement is the stream function is defined so that incompressibility condition is automatically satisfied. Okay, when we will decide the incompressible, when we will define stream function, so the incompressibility condition automatically satisfied. So the Laplacian del square phi is equal to 0 hold only for 2D relational flow. Yes, you can write this one. So I think these two is the same. This option A and C is the correct. Both. Yeah, here is both is correct. Because del square means this. Del square by del x. If psi is there, then del square psi by del y is equal to 0. This is same. Both A and C will be correct. Okay. Option C. Question number 6. The velocity potential function phi and stream function are related by, because u is related to yours, u is the function of psi and phi, and v is also the function of psi and phi. So from here you can relate the things. So option A is correct. Remember. The velocity component for 2D flow u del psi by del x v, and this represent your obviously your stream function. The which of the following indicate the rotational flow? Does not equal to 0. This will be the rotational flow. The volumetric flow rate across a surface is given by volumetric flow across a surface. So across a surface we are talking about. So velocity into A, no, this will be the correct option. So remember please. And which of the following must be satisfied? Though remember the expression is the given here. The explanation is given already. Next one, which of the following must be satisfy the irrotational flow? Remember irrotational, yes, curve will is equal to 0. This will satisfy the irrotational. So the final explanation is given. So this is all about for the today class. So we'll in the next class we'll discuss about the whatever the topic will be there. So I'll prepare the slide like that. So if anyone have any doubt after go through the all questions and videos, full length video, if anyone have any doubt you can ask in the next class. So thank you.